Hi everyone, today I am going to discuss the indefinite integrals, and at the end of this video you are expected to be able to illustrate integration and differentiation as inverse operations, illustrate the definition of indefinite integral, identify the appropriate property of indefinite integrals applicable for a given integrand, and apply appropriately the power formula of integration. In differential calculus, we learned new operation called the differentiation to obtain the answer called the derivative or the differential. That is, in the differentiation process, we are given the function y and we are required to find for the derivative of y denoted by the symbol derivative of y with respect to the independent variable, or to find for the differential of y denoted by the symbol dy. Take note again that the differential of y is equal to the derivative of y multiplied by the differential of the independent variable. In integral calculus, you will be introduced to a new operation called the integration. In the integration process, you will be required to find for a function called the integral. That is, in the integration process, we are given the differential of a function, say dy, and we are required to find the integral or the function y whose differential is equal to the given integral dy. So notice in here that the differentiation process and the integration process are inverse operation. That is, we are given in the differentiation, we are given y, we are required for the differential of y. In the integration process, we are given the differential of y, and we are required to find for dy. And so integration is also known as anti-differentiation. And the required integral is also known as the antiderivative. Let us have a clearer understanding on how inverse operations work together. We know that addition and subtraction, multiplication and division, raising to powers and extracting roots are inverse operations. So let us illustrate how they work together. If let us say we are given a number 20, if we add 25 into 20, it will give us 25. So applying the inverse operation of addition, which is subtraction. So from 25, if we subtract 5, it will give us back 20. Let us take another number, 4. If we are going to multiply 4 by 8, it will give us 32. The inverse operation of multiplication is division. So if we are going to divide 32 divided by 8, it will give us back 4. Let us have another example, 5x. If we are going to raise 5x into the exponent 2, it will give us 25x squared. Raising to exponent 2 has its inverse, square root. So if we are going to extract the square root of 25x squared, it will give us back 5x. So I hope you now understand how inverse operations work together. So the inverse operation undo what its inverse has done into the given expression. Let us now illustrate how the differentiation and the integration or anti-differentiation process work together as inverse operations. So in the differentiation process, we are required to find for the differential, and it is denoted by the symbol small letter d. While in the integration or anti-differentiation process, we will be required to find for the integral, and the symbol used is, this is the integral sign, an elongated S. Let us now illustrate these two operations as they work together as inverse operations. So let us have the function 5x cubed. Finding the differential of 5x cubed, applying appropriate differentiation formulas, this will give us 15x squared times the differential of x. Applying now the inverse of differentiation, which is integration. So integrating 15x squared dx, it must give us back the function 5x cubed. We have here the square root of 2 plus x. Differentiating square root of 2 plus x, or finding the differential of square root of 2 plus x, applying appropriate formula, it will give us differential of x all over 2 square root of 2 plus x. So applying the inverse operations, integrating dx all over 2 square root of 2 plus x, it must give us back the original function square root of 2 plus x. Or we have here sine 3x. The differential of sine 3x is 3 cosine 3x times the differential of x. Integrating then 3 cosine 3x dx must give us back sine 3x. So this is how integration and differentiation work together as inverse operations. The integration process undo what the differentiation has done into the original function. So it will give us back the original function. The problem, however, in the integration process is we are not given the original function and the different how we obtain the given differential, because the problem is usually starts with integrating a given differential. So that is what we are going to find out later as we derive more integration formulas. Let us now define an indefinite integral. Let us consider the following functions. 5x cubed. Differentiating 5x cubed will give us 15x squared times the differential of x. Another function, we have 5x cubed plus 10. Differentiating 5x cubed plus 10 is equal to 15x squared times differential of x, knowing that the differential of a constant is 0. If we have another function, 5x cubed minus 2, differentiating 5x cubed minus 2 will again give us 15x squared dx, because the differential of minus 2 is 0. If we have 5x cubed plus 5, finding the differential of 5x cubed plus 5 is equal to 15x squared times differential of x. So observe in here that these functions differ only by constants, and each differential are the same. So we have here in all these functions which differ only by a constant, we have their differential are the same. So applying now the inverse operation, that is integrating 15x squared times differential of x, can either be equal to 5x cubed or 5x cubed plus 10 or 5x cubed minus 2 or 5x cubed plus 5 or any function 5x cubed plus any constant, as we know that the differential of any constant is equal to 0. So that is why when we integrate 15x squared times differential of x, it will now be equal to 5x cubed plus c, where c in here represents any constant added to the function 5x cubed. We call this an arbitrary constant. That is why we call this as indefinite integral. When you are integrating a given differential, it is called an indefinite integral because your answer is indefinite. There are many functions in your answer which differ only by a constant, hence indefinite integral. So we have here, C is called the arbitrary constant or the constant of integration. Let us now write the definition of indefinite integral using symbols. We have this symbol, this is read as the integral of a given differential of a function is equal to the function itself plus the arbitrary constant c, where in this statement, the f prime of x dx is what we call the integrand, and it always represents it is always a differential of an unknown function. Okay, so this unknown function f of x plus c is what we call now the indefinite integral. So this is an unknown function whose differential is equal to the given integrand. So we use the different integration formulas in finding this integral together with the different properties of indefinite integral. The first property is if you are going to integrate two or more differentials, so you just get the sum of the integral of each term. So integrating sum of differentials is equal to the sum of the integral of each differential. The second property is if the integrand contains a constant factor, you just write the constant factor outside the integral sign, then proceed with integrating the remaining differential. The third property is you have the integral of a differential of a function. You may introduce a constant factor in your integrand, but at that same step, you have to multiply outside this integral the reciprocal of the introduced constant. This reciprocal, we call it the correction factor. Let us now derive some integration formulas. So first, let us consider the function u. Differentiating u will give us du, or the differential of u. So that if we are going to integrate the differential of u, it will give us back the function u plus the arbitrary constant c. This first formula is actually the definition of our indefinite integrals. That is, the integral of the differential of a function is equal to the function itself plus the arbitrary constant. In the next formula, let us consider the function u raised to n plus 1. So finding the differential of u raised to n plus 1, we make use of power formula. And that will now be equal to the exponent times the base raised to the exponent minus 1. So the exponent minus 1 is n plus 1 minus 1. So that will only be u raised to n times the differential of u. Then applying the inverse operation, that is, we integrate this differential, the integral of the quantity n plus 1 times u raised to n times differential of u, it will give us back the original function u raised to n plus 1 plus the arbitrary constant c. So take note in here, when we apply power formula in finding the differential of u raised to n plus 1, n plus 1 in here is a constant. That means this quantity n plus 1 is a constant. So simplifying now this statement, we can apply the second property of indefinite integral where the constant factor may be written outside the integral sign. And then we can divide now both sides of the equation by the quantity n plus 1. So that will give us now the integral of u raised to n times differential of u is equal to u raised to n plus 1 divided by n plus 1 plus c all over n plus 1. So take note, in this statement, that c in here is an arbitrary constant. That means it can represent any constant. And n plus 1 is also a constant. So an arbitrary constant divided by another constant will give us another constant. Hence, we now have the formula of, or the power formula of integration, that the integral of u raised to n times du is equal to u raised to n plus 1 all over n plus 1 plus the arbitrary constant c. Take note that in this formula, n must not be equal to negative 1. Let us now apply the formula that we just learned in evaluating indefinite integral. So remember that as of this time, we only have two formulas available: the definition of the indefinite integral and the power formula, together with the properties of indefinite integral. So notice that we don't have a formula available for functions which contain square root in the denominator. So what we're going to do is write or rewrite this function into an integrable form. So we can write the square root of x in the denominator as We now have in here the integral of x raised to negative 1/2 times dx. And notice that we can now compare this one to the power formula of integration. Now, in applying the formula, what you're going to do is compare and evaluate the elements of the left side of the formula with the given integrand. So in the power formula, we have three elements in here, u, n, and du. What you're going to do is assign the value of u and n directly taken from the given integrand. So as we compare this integrand with the left side of the power formula, notice that n in here will have the value negative 1/2. The base of the exponent n in here is u. The base of the exponent negative 1/2 in here is x. So that means our u is equal to x. After you define n and u directly from the given, your next step is to evaluate the differential of u directly from this value of u. So that means we now have the differential of u is equal to, we differentiate also the right side, that will be equal to the differential of x. Your next step is to write the values of these elements in u and du following the left side of the power formula. So recite the left side of the power formula, write the values of u, n, and du as defined in here. So we now have the integral of u, whose value is x, raised to n, which is negative 1/2, times du, which is dx. This function now follows the left side of the power formula. Your next step before you proceed to writing or applying the right side of the power formula is you have to compare if this function is equal to the given function. So we have here the given is integral of x raised to negative 1/2 times dx. Our new function is integral of x raised to negative 1/2 times dx. Notice that they are exactly the same. And so we can now proceed to the next step, which is to apply the right side of the power formula. So recite now the right side of the power formula. In the next step, that will now be equal to u, which is x, raised to n plus 1. So you have negative 1/2 plus 1 all over n, which is negative 1/2 plus 1, plus the arbitrary constant c. So we are now done integrating. We just need to simplify this function. We now have x raised to 1/2 all over 1/2 plus c, or we can write this as 2 square root of x plus c. So to check if this function is correct, you have to differentiate the final answers. As we define our indefinite integral as, we are going to find a function whose differential is equal to the given integrand. So we try to check if the differential of our final answer, 2 square root of x plus c, is really equal to the given integrand. So we now proceed with differentiation. The differential of sum, so we differentiate each term separately. This will be 2. Differential of square root of x is differential of x all over twice square root of x, plus the differential of c. So we try to check if these two are really equal. We simplify this. We now have dx all over square root of x. We know, of course, that differential of c is constant is 0, and we have now that is equal to the given integrand. So we make the conclusion that this function is the integral of dx all over square root of x. In the next example, we are required to evaluate the integral of 4x cubed plus 3x minus 1 times dx. So again, in integrating a given integrand, all you need to do is compare this function with the left side of the formula. Now, there are only two integration formulas that we have already discussed. The first one is the definition of indefinite integral, whose left member is the integral of the differential of u. As we compare this one with the given, other than dx, we still have this factor. And so therefore, we cannot apply this formula. The second formula is the power formula. The integral, whose left side is the integral of u raised to n times du. So as we compare this integrand with the given integrand, we have now in here, other than dx, is the factor, the quantity 4x cubed plus 3x minus 1. That would represent our u. And if we are going to evaluate this u, obviously we will have a du containing a factor other than dx. Therefore, we cannot apply the power formula. So our next step then is to think of a way where we can rewrite the function in another form. And we know in algebra that we can distribute dx into each term. So we have now the integral of 4x cubed plus 3x dx minus dx. Then we can apply now the property of indefinite integral, that if the integrand contains two or more terms, then we can integrate each term separately. So integrating now 4x cubed dx, we again further apply the second property, that if the given integrand contains a constant factor, we just write it outside. Similarly, in the second term, 3 is a constant factor, so we can write it outside. Then minus integral of dx. So we know we have a formula for integral of du, and that is equal to u plus c. Therefore, the integral of dx is equal to x. Supposedly, we have the arbitrary constant plus c. However, since there are still integral sign in the other two terms, we do not add arbitrary constant c in here. Then we continue. In the first term, the integral of x cubed dx, we can apply power formula. Notice that this function follows the integral of u raised to n times du, where our n is 3, u is x, and obviously the differential of x is dx. So it really satisfies the left side, and so we can, left side of the power formula, so we can now, in the next step, apply the right side of the formula, that the integral of u raised to n times du is equal to u raised to n plus 1 all over n plus 1. Similarly, in the second term, our u in here is x, n is 1. And so we therefore have 3 times x raised to 1 plus 1 all over 1 plus 1. The third term do not contain integral sign, so we just copy. Since we have now eliminated all the integral sign, this is the time that we add arbitrary constant c. So we are now going to simplify the function to get the final answer. So to check if this function is correct, again, we go back to the definition of indefinite integral, that if we are going to integrate the given integrand, which is a differential of the function, then the differential of the obtained function should be equal to the given integrand. So this is how we check. Try to differentiate your final answer and check if that is equal to the given integrand. So we have here the differential of x raised to 4 is 4x cubed dx. The differential of 3x squared dx is, we can factor out the constant factor 3 halves, then the differential of x squared is 2x dx, minus the differential of x is dx, and the differential of c, of course, is 0. So we check if these two are equal. 2 in here cancels out, and we know that each term contains dx, so we can factor that out. That gives us now 4x cubed, or the quantity 4x cubed plus 3x minus 1 times dx, and obviously it is equal to the given integrand, and so therefore we say that this function is the final answer, as its differential is equal to the given integrand. In the next example, we are required to evaluate the integral of the square of 3x minus 1 times dx. So again, in integrating a function, all you need to do is compare the given integrand with the left side of the formula that you desire to apply. So here we could try applying the power formula, whose left side is the integral of u raised to n times du. As we compare these two, obviously, the exponent n in the formula will be equal to 2 in the given integrand, and then the base u, which is 3x minus 1, and then the differential of u in the formula will be evaluated directly from this value of u. So du is equal to 3 times the differential of x. Then the next step is to write a new function following the left side of the formula with the value of these elements equal to these defined values. So we have now the integral of u, which is 3x minus 1, raised to n, which is 2, times the differential of u, which is 3 dx. Your next step is to compare this new function to the given function. So as we compare these two, notice that the new function contains this constant 3, which is not found in the given. However, the second property of indefinite integral allows us to multiply a given integrand by a constant factor for as long as in that same step you have to multiply its reciprocal outside the integral sign. And so you will notice now that the value of this function is now equal to the given function. So we are now ready to apply the right side of the power formula, which is u raised to n plus 1 over n plus 1 plus c. So the constant factor outside is just copied. Then we have now our u raised to n times du, and that will be equal to u raised to n plus 1 over n plus 1, and then plus the arbitrary constant c. So as we simplify, we now have 1 over 9 times the cube of 3x minus 1 plus c. Again, to check if this final answer is correct, all you need to do is just differentiate this function and try to find out if you arrive at this differential. So I will introduce to you another step of integrating the given function. So we know that in algebra, we can expand this binomial 3x minus 1, quantity squared, and that will give us now the integral of 9x squared minus 6x plus 1 times dx. And then we can apply the first property of indefinite integral, where we can just distribute dx into each term and integrate each term separately. Then integrating now the first term, 9 is just outside the integral sign, so we just copy. Then the integral of, this will be our u raised to n times du. So if n is 2, u is x, du is just dx. So it gives us x raised to n plus 1, that's 3, all over 2 plus 1, that's equal to 3. Same formula will be applied in the second term. So we have integral of u is x, n is 1. The differential of x is dx. So we have now x raised to 1 plus 1 all over 1 plus 1. Then plus the integral of dx, we can apply in here the definition of indefinite integral, where the integral of the differential of u is equal to u plus c. So the integral of differential of x is equal to x. We have now eliminated all the integral sign, and so we add arbitrary constant c. So simplifying, we now have 3x cubed minus 3x squared plus x plus c. Again, to check if this answer is correct, you have to differentiate the final answer and try to find out if you will obtain at the same function. Further, we can compare these two answers. If this function, take note in the definition of indefinite integrals, the integral of a given differential will have an answer or a function whose final functions which can differ only by a constant factor. So let us try to check. If we expand this, we now have 1 over 9. This is cube of binomial. That would give us 27x cubed minus 27x squared plus 9x plus c. Simplifying further, we now have this 3x cubed minus 3x squared plus distribute x plus 1 over 9 plus c. So as we compare these two, notice that they just differ by this constant factor. And that satisfies our definition of indefinite integral. That when we integrate a given integrand, we can have many or indefinite number of functions. Each function differ from each other by a constant term only. And so since we have an arbitrary constant and this is a constant, we can just further write this as 3x cubed minus 3x squared plus x plus c. So this will now be our final answer. In the next example, we are required to evaluate the integral of the square of x cubed minus 1 times dx. So as we compare the given integrand with the formulas that we have already discussed, then we could compare this one with the power formula. So in the power formula, we have the left side is integral of u raised to n times differential of u. So as we compare these two, n will have its value equal to 2, while u is the base of the exponent x cubed minus 1. And the differential of u is evaluated directly from this value of u. So that will give us now 3x squared times dx. Then the next step is to write the new function following the left side of the desired formula we want to apply. That is the integral of u, which is x cubed minus 1, raised to n, which is 2, times du, which is 3x squared dx. So before you apply the right side of the power formula, compare these two. So as you compare, notice that this given function and the new function differ by a factor 3x squared. So if the two functions differ by a factor containing the variable of integration, that means you cannot apply the desired formula you want to apply. So erase this whole thing and think of another way of differentiating or writing the function. So we know that square a binomial can be expanded, and that will give us now the integral of x raised to 6 minus 2x cubed plus 1 times dx. And we can distribute dx into each term and integrate each term separately, applying the first property of indefinite integral. So in the second term, since 2 is a constant factor, we can apply the second property, and that gives us now the function, the integral of x raised to 6 dx minus 2 times the integral of x cubed dx plus the integral of dx. So here we can now apply the power formula in the first term, and that will give us x raised to 6 plus 1, which is 7 over 7 minus 2 times, this is our n is 3, so 3 plus 1 is 4. So we have x raised to 4 over 4 plus the integral of dx, applying the definition of indefinite integral, that is x. Since we have already eliminated all the integral sign, we add arbitrary constant c. So we just simplified the function for your final answer. Okay, plus x plus c. So to check if this function is correct, you just differentiate the final answer, and I hope you will be able to find its differential equal to the given integral. In the next example, we are to evaluate the integral of 2a dx all over the square root of 4a minus 3x. This factor dx tells us that the variable of integration is x and that all the other letters in the integrand will be treated as constant. That means a in here is a constant. So we start our solution by first, since 2 is constant and a is constant, 2a then is a constant factor, and we could apply the second property of indefinite integral. So writing it as 2a times the integral of the square root in the denominator may be written in power form as the quantity for a minus 3x raised to negative 1/2 times dx. So we can now apply power formula for this function, following the form, the integral of u raised to n du. So we define our n, that will be the exponent negative 1/2. The base of this exponent will now be the value of u, that's 4a minus 3x, and du will be evaluated from this assumed value of u. So if 4a is constant, then that will give us now differential of u is equal to negative 3 times dx. Writing now our new function, first we copy the constant factor outside the integral sign. Then we try to apply in here power formula. So we have the integral of u, which is 4a minus 3x, raised to n, which is negative 1/2, times du, which is negative 3 dx. Then before we apply the right side of the power formula, we have to compare if these two functions are equal. So obviously, as we compare these two, they just differ by this factor, negative 3. And that allows us to apply the third property, that is, we multiply this new function by a constant factor, the reciprocal, which is negative 1/3. So these two functions now are equal, and we are now ready to apply the right side of the power formula, that the integral of u raised to n du is equal to u raised to n plus 1 all over n plus 1 plus c. First, we copy the constant factor outside, is negative 2a over 3, and we have our u, which is 4a minus 3x raised to n plus 1 all over n plus 1 plus c. And we just simplify this for our final answer, negative 4a over 3 times the quantity 4a minus 3x raised to 1/2 plus c. So I will just leave to you the checking if this answer is correct. So you just need to differentiate this and obtain the given integrand as its differential. Let us now evaluate the integral of sine cube x over 2 cosine x over 2 dx. So in this function, take note again that this exponent 3 has its base sine and its angle x over 2. So we can try applying in here the power formula. The integral of u raised to n du is equal to u raised to n plus 1 over n plus 1 plus c. So we compare the given integrand to the left side of the power formula. So here we can have the value of n, which is the exponent, equal to 3. The base of the exponent 3 is sine x over 2 as the value of u, and the differential of u will be evaluated directly from its value. So we have the differential of u is equal to the differential of sine angle, which is equal to cosine angle times the differential of the angle. So further, we have the differential of x over 2. We can just factor out the factor 1/2. So we have cosine x over 2, 1/2 times the differential of x, or we have 1/2 cosine x over 2 times dx as the value of our du. Writing now the new function following the left side of the power formula, which is the integral of u raised to n times the differential of u, which is 1/2 cosine x over 2 times dx. Comparing these two functions now, we know that sine cube x over 2 is equal to sine x over 2 quantity raised to 3. The cosine x over 2 times dx is also found in the new function, but the new function has this constant factor 1/2. Again, we can just correct the presence of this 1/2 by multiplying its reciprocal outside the integral sign. So these two functions now are equal, and we are now ready to apply the right side of the power formula. This is the integral of u raised to n times du, and that will be equal to u raised to n plus 1 all over n plus 1 plus the arbitrary constant c. So simplifying, we now have our final answer as 1/2 sine raised to 4x over 2 plus c. This is now our final answer. So to check, you can just differentiate this final answer and try to find out if you will arrive at its differential equal to the given integrand. I will end up my discussion in here. I hope you learned something from this presentation. Thank you for watching.